Hello, it's Leo again. Today we're going to talk about another LeetCode problem. It's called Rainbow Sword 2. Now let's read the descriptions. Given an array of balls where the color of balls can only be red, green, blue, or black. So basically it's like the Rainbow Sword 1 we just talked about. And the difference is we have one more color to sort. And sort the balls such that the balls with the same color are grouped together. Yeah, the same thing here. And from left to right, the order is, we can denote it with numbers 0, 1, 2, 3. So let's take a look at the examples. The first one is if there's only one element here, it's sorted to the only one element. And if it's 0, 1, and because the problem says there's an order, right? So the order is 0, 1, 2, 3 from left to right. So it's sorted to 0, 1. And in this case, where there are multiple colors, it's sorted to 0, 1, 1, 2, 3. Okay? So let's first talk about the corner cases. The only corner case we could think of as an array is if the array is null, or if the array contains only one or less than one, let's say 0 elements. So if that's the case, we're going to just return the original array. That's what happens with the first element, okay? With our first example. Okay, so let's talk about the next moves. Let's say we have sorted everything here. Let's say 1, 1, 1, 1, 2, 2, 2, 2, and we have multiple unknown right here. And let's see, that's 0, 1, 2, 3. Okay, I'll include it. And how many pointers do we have? First, we're gonna need one thing to separate 0 and 1, and another one with 1 and 2, and we're gonna use a third one to sort the unknown size. And the last one is going to be called L to separate the unknown from the 3, the last group. Okay, so how do we start? We're going to start with defining all these pointers. So we're going to define int I equals to 0, int j equals to 0, int k equals to 0, also int L equals to array.length minus 1. Okay? Just like what we did in our Rainbow Sword 1. We're just adding one more pointer to it. Okay. So the only thing that k could work is while k is less than or equal to L. Okay? If k is larger than L, that means all the unknown elements were sorted. So we can quit the loop and return what we have, okay? We can return the array afterwards. Great. So let's see how it works in the looping. Let's say the first case scenario is when the element is 0. If array k is equal to 0. How are we going to do that? We're going to swap it with I, the ith element, and then we're going to move I to the next one, right? That's very instinctive. However, there's one problem here. We can do that with Rainbow Sword 1, where there's only 3 colors. But in this case, we have another pointer here, which is j. Let's think about this case scenario where there's like this. Okay, no, there's no 8 or 3. Okay, so in the original state, we're going to take I here, j here, k here, and also L here, okay? So in this case, if we're unable to move I and j apart, there might be some mistakes, okay? So in this case, the safest thing to do is to swap it with j, and then swap it with I, and then move the pointers accordingly. That's what we're going to do. So you can see we're going to swap array j with k, okay? So we're going to move it right here. When it's swapped to 2, and this is to 0, right? And now, since this is sorted, we have to move k to the next one. So we're going to move k plus plus. And then, are we going to move j to the next one? Well, apparently not, because we're going to swap j with I, okay? So the next thing we're going to do is swap array I, j, okay? So this is swapped to 1, and this is 0. Okay, now we can move j to the next one, and I also to the next one. So we're going to move I plus plus and j plus plus. Okay, does it look good? In this case, j is still the first element of the 2 group, and I is the first element of the 1 group. K is the first element of our unknown group, and L is the last element of the unknown group. Okay? So far so good. Okay, so else if array.k equals to 1. Let's see how it works. So if this is 1, we're going to swap it with j. Okay? So this is swapped to 2, and this is swapped to 1. And after that, we're going to move k to the next one, and also j to the next one. So that's swap array j plus plus k plus plus. Okay, hope that works. Okay, the third thing is if array k equals to 2. If that equals to 2, no, we're lucky. We don't have to do anything. So we're going to just move k to the next one. So just k plus plus. And else. The last one is when it's equals to 3. We're going to swap it with L, right? Since L represents the last one of the unknown array, this time we don't have to move k to the next one. However, we have to move L to its previous one to make sure that L is the last element in the unknown array. So this time we're going to swap array k and L and make L to the next element. Okay, that looks good to me. The next thing is we're going to write another function called private swap. The input is int array, int a, int b, okay? And we're going to set it into temp into array a, and array a equals to array b equals to temp. Let's do some final check. If there is no, to see if there's any typo or something wrong with it. Okay, looks good to me. Let's test it. Oh, okay, it's the same. And let's see if it could work. Okay, accepted. Very good. So let's talk about the time complexity and space complexity. Since we're not creating anything new, I believe the space complexity is O1. And since we're traversing the whole array, the time complexity should be ON. Okay, that's it. If you like the video, please give me some subscribe and like the video on the bottom. Okay, I'll see you next time.